Yo, 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 what's up? Let's continue with this water once again. And I think I've actually decided we're gonna do sort of a unoptimized implementation today to fix the last thing that has to do with the outlines and water. So we can move on to some more fun stuff. And then I'm just gonna create an issue, or I'm just gonna put the task of optimizing it on FutureMe's desk. I have a few approaches that could be viable, but I don't want to explore them today. But let's just see what I'm talking about. So we can properly recolor outlines, and we can properly blur outlines above and below the surface. But we have a little bit of an artifact left, and that's with outlines above the water. When we blur them, they get included in the blur, and so yeah, that's not good. What's up, Cooler SK? So yeah, as I said, today we're gonna go with the simple but unoptimized solution for this problem. So we're hopefully gonna fix it, but it's gonna be costly. And then I'm gonna create an issue or a task for FutureMe to revisit it and fix it. Don't know when, but just so we can continue with the actual visuals of the water, and so we don't have to care that much about the outlines themselves. So let's see here. Train procedure water. And it's within here, so we're actually going to take this part right here and put it into its own function. Good morning, E-Dragon. And we're going to do bool is... Do I want it to be in front or behind? Seen in front of pixel. We're going to rename this one. We're going to do is rendered behind, I think. Is rendered behind. And what we're gonna send in here is float to UV. So this is the UV for the rendered image. And then we're also gonna send in float is rendered behind. What do I want to call this? Is rendered behind. Maybe compare depth. I think that's everything we want to. One more thing. Is rendered behind UV, and we're gonna send in texel size. And kernel or check kernel size. And now we do this. Yeah, then we want to read depth. And yeah, we're gonna have to do this multiple times, but yeah, that's the unoptimized way. We read depth, we have compare depth, and we want to check if this is compare depth. Seen in front of pixel. One sec. I keep forgetting. Let's see here. If depth is bigger than pixel depth, then we wanna, yeah. So is rendered behind. Yeah, what we want to do here is float smallest depth is equal to we had cull parameters. Let's see. Or not parameters, but, or let's see. Projection params, and we want to go with Z. Okay, so smallest depth, we take this one to be the biggest depth initially, and then we check if depth is less than smallest depth, or rather if smallest depth is bigger than depth. And we do this, so, and then we return if smallest depth is less than compared depth. Let's see here if it is okay. So if smallest depth is less than compared depth, that means that this one is in front. So we actually want to do this. So if the smallest depth of all these pixels are, if it's bigger than this one, then rendered is behind, yes. We can clean this one up as well, but let's see. The worst part with this is we're gonna do it multiple times, but I'm okay. Let's see here. I don't care about abs here. We're gonna clean this up even more because this is costlier. So let's see, rendered color, accumulated color count. Depth. Yo, what's up, Nastenka? Nastenka, which software are you using to keep your notes about game development? It's not that. It's really not about the software. It's like I vary the software, but I make sure that I have pretty much everything related to this project or most of my projects on GitHub, and then sometimes I edit the notes directly on github.com, and sometimes I do it in VS Code. I think GitHub has a pretty good tool set for keeping track of your project. Works great. It's very well integrated with the code and stuff like that as well. Okay, so I don't care about this, I don't think. No. Fuck this. We're gonna do it like this. Kernel size. We're gonna change to this. We're gonna remove that one. Depth, and then we can remove all of this, I think. And instead, what we're gonna do within this check here, like this. So within this one, we're actually gonna do if is rendered behind, so that means that whatever is in rendered colors is behind this one, then one sec. Yeah, we need to send in UV texel size, check kernel size, and here we're gonna do outline kernel size, and lastly we're gonna do compare depth. So no. I wonder if we can skip this one. One sec, that is not true. Compare depth. The compare depth we want to send in here is actually pixel depth. So like that. So basically what we're doing here is we're doing a kernel here and we're doing a kernel here. So it's a kernel within a kernel, extremely costly. But I don't really see no other way right now. I wonder if everything is correct though. Okay, so far this one pretty much just decides if it's going to be included in the blur or not. And let's see here. I think we want to do, instead of this one, scene in front of pixel is rendered behind. Fuck, is rendered behind, UV center, texel size. Okay, let's try this one. I don't know. Let's see. Fuck, did I do something I don't want to do? Maybe. Yo, what's up, Derek? Ooh. Should be okay, I think. Yo, good morning, Geralt. Yeah, I don't know what Unity is doing right now. It doesn't want to work with me. Oh, actually. Forced to unroll loop, but unrolling failed. Okay, let's take a look at that one. 265. Loop does not appear to terminate in timely manner. 619 iterations. Or unroll loop is too large. Fuck me. But let's see, 265. Why? Kernel size. Yeah, I'm pretty sure we have a max and min here. 0 and 10, it should be okay. Is rendered behind. Adds. Yeah, we're pretty much doing. Does it really become that big? Okay, one sec. Yeah, that doesn't bode well for this. Remember I said it was going to be an unoptimized solution. Definitely highlights the unoptimized in the name. But still shouldn't be close to 619 iterations. No, I don't think so. Plain. Or it shouldn't be that much if we got it working correctly. 1, 2, yeah, we don't change anything. And then we change. We do. This one actually works. Down here we can see it that the outlines on the outside works and it works inside. Okay, so this one works. We just it doesn't seem to we don't seem to be able to do an extra kernel in a kernel, which sucks. But one sec. Maybe we just want to read a lot of data here and cache it. Cache it. And then Do I dare uncomment this? Okay, and then if we do 1, whoa, it still didn't work. It's rendered behind. I just need to check this. So if we send in outline kernel size here, I think this one should be 1 actually. Why are we getting a problem as soon as we change that one to okay, something is wrong. And I wonder, okay, so let's do this. I think, so if this one is, it sucks that it works here though. If this one is properly instantiated, it should be 1 here, but it's a global property. So I don't know when and how they are set. But if this one is 1, it should be okay. Okay. So let's switch it back to 1. (619 iterations. What do we have? We have 1, so 3 times 3, we have 9, and then 9 times 9. We're looking at, what is it, 81? It should only be 81 iterations, not 619. Okay, so if we have 3 times 3, that's 9. What multiplied with 9 becomes 619? Let's see. 619 divided by 9. 68-ish, 69. But that's just the maximum until we stopped. I have no idea why it tries to iterate that many times. Because if we take a look at outline kernel, we set it here. Outline kernel site, set global integer on create here. Outline kernel size. And it's currently 1. And if we set 1 here, then it works. But if we set outline kernel size here, then it doesn't. So I wonder, let's just add, let's do this. Int kernel size is equal to max or min of 1 and check kernel size. So we're always going to pick 1. Maybe we can have a max here. Outline kernel size. Let's see what we have. Oh, is it because this one is negative when it's not initialized? Oh, whoa. Maybe. Wow. But still, it should be initialized to 1. I don't get it. And 7 iterations. Oh fuck it, let's do kernel size clamp 0 1. Check kernel size. That doesn't work either. This is very weird. Outline kernel size is rendered behind. Check kernel size. So if we just switch to 1 here, we're still getting problems. Fuck. -1 to 1, -1 to 1, -1 to 1, -1 to 1. What do we have? I think, like, at most, with this setting, we should have 3 times 3 times 3 times 3. 81. So... okay, now we don't even have outlines anymore. Okay, makes sense. Yeah, are we trying to oh, yeah, I get it. Are we trying to... yeah, I want to give... we want to set them... what is it? Unroll. Set max unroll. HL7. Five iterations only. Yeah. Try this. I want more information. Yeah, I want to try with unroll later on, but unroll. So what the fuck if we just do... if we do... unroll. I don't think we're doing it just yet, because... are we? 1. Okay, we're doing it once now. I think we are, but we're still not getting the correct... size 1. Why are we not getting the correct value here? Am I misunderstanding something? Let's see. It's rendered behind. First of all, we're going to change this one to outline kernel size and hope it doesn't crash. Okay, it looks better. So we just tell it to, we set a, or actually does it crash? No. Okay, we just tell it to unroll it a maximum amount of 9, or a maximum of 9 times. We're on thin ice right now, it feels like, but let's see. It's rendered behind. So for something to be included in rendered color, it needs to be, is rendered behind, it needs to be behind the current. And here we do smallest depth, we get the smallest depth. That should be correct. Yeah, it definitely works here. I wonder if, I think it works here. It sort of works. Oh, whoa, whoa, whoa. Yes, one sec. The fuck? Yeah, I think it works, because previously we had previously it looked like this. Let's see. You can see the outline being included in the blur, while with this solution we just don't, or we pretty much just remove it. So that means that we don't take it into account, but then finally when we're gonna do whatever we're doing here, it doesn't really work. So it's rendered behind. Yeah, I think we need to, the fuck are we doing this here for? I don't know. Okay, what exactly is happening? So, yeah, we don't include it in rendered color. But then if rendered color has an alpha that is bigger than 0, Yeah, we pretty much want to do something. Yeah, this one we already check. Okay, what do I think happens? I think rendered color A. This one should have an alpha bigger than 0 for this outline, for instance. This one is rendered behind. This one should return false. So this one should be true, this one should be true. And then we do this weird check, previous depth. So that's the depth we had previously, and this is the pixel depth. If the previous depth, yes, I think, how did this work previously? I think that this one yeah, definitely. Sorry about that. This one needs to be the accumulated depth, or not the accumulated depth, but the smallest depth. So we don't really care about. We need to. I think I'm gonna re-implement this method, so instead of returning a bool, it actually returns the smallest depth value inside a kernel. So we're gonna do float get smallest depth in kernel, or do I really want to call it a kernel here? Yeah, why not? Get smallest depth in kernel, and then we just do this. We do this, and we just return smallest depth, and then we don't need compare depth. And here we do get smallest depth in kernel, pixel depth, and if this one is bigger than pixel depth, then we're behind, so we can do this. But do we want to store this one and reuse it, or pixel depth? I'm still not fully understanding this one. Or maybe do this. Seven UV. What exactly is happening here? Let's see here. If we have an outline and the render is not behind, then we check the middle pixel. Previous depth, if it's less than pixel depth. Fuck me. But this... If we just check the middle pixel, wouldn't that screw it up for us? So this one works. We're not taking the outlines into account when we blur. When we calculate the final color. So we have a final color. If alpha is bigger than 0, so one of them is... one sec. Gigantomecha, do you have an ArtStation account? No, I don't. Yu Xiang Wu, sorry about the pronunciation. What's up, what's up? What am I missing here? So if any of the pixels are part of an outline and it's not rendered behind, then we check them. I don't think this is exactly what we want to do this time around. But I'm still a little perplexed over the fact that this works for... Oops. What is it? This one, right? Pixel depth. I'm still a little bit shocked that it works for this case. But if we have a kernel size of 1, so if we have a kernel size of 1 for this pixel right here, we want to blur it. Yes, we're fucking up rendered color here. Yeah, what I think happens is yes. What I think happens is that we do rendered colors here, but we remove all of them that are related to. So when we check this pixel, we don't add it because it's part of this object, so it has a smaller depth, which means that rendered color here doesn't have an alpha bigger than 0, so we just return this one. Okay. I don't think we want to do this either. But rendered color alpha here is 0. But. Fuck it, let's do it like this. Rendered color. Let's do accumulated rendered color. And okay, this still works. Or does it? Yeah, I think so. And if we add a kernel of 1, yeah, we'll remove these again. What the fuck? Look at the performance here, it's abysmal. What the fuck? Extremely big. 126. Luckily 1 gives a pretty good result. I don't even know. Like, honestly, I'm not sure yet how we want to do, what path we want to go when we go with the water. Like, do we actually want to blur whatever is underneath the water? I've been having this idea that we might want to blur it based on water depth. So the further down in the water it is, the more we want to blur it. But I don't know just yet. We're gonna do some experimenting with it eventually. But first we need to fix this one. So what the hell? When we do kernel 1, we still don't involve these. So if rendered color A, this one should return true now for one of these pixels. Get smallest depth in kernel, if this one is less than, yeah, maybe this one returns false then. Still don't fully understand. Okay, so if we have an outline, this is what happens if the outline is above. No, behind. And this is what happens if the outline is in front. Why the fuck do we have this one here? This is how I think it should be. So color is equal to final color accumulated rendered color. And then we check if the rendered color, like at this pixel, is it part of the outline? If so, do this, otherwise just return the color. And so we do previous depth here, which I think is wrong. So what we want to do here is we want to check if we get the smallest depth in kernel and we do outline kernel. So now we have the depth value closest to the camera, that's part of the outline, or that make up the outline. If this one is bigger than pixel depth, that means that the full outline is behind this one. That means that we should just do this. Otherwise, we're here and we just do this. I don't understand why this doesn't give the correct result, but maybe it does. Or did we have a problem? We have this problem right here then. Let's take a look. Interesting. I'm gonna look into this one soon. I just want to see what the fuck. Okay, so we have this issue. We have this issue, and now we have this issue as well. So if we take a look at this one, honestly, I'm not entirely sure about this one. Color. If rendered color alpha is bigger than 0.0, yes. And get smallest depth in kernels is less than this one. Yeah, then we have this one. Otherwise, we just return color. Did I do it in an overcomplicated way previously? It looks that way. So this works for this one, as previously, but not for this one. The hell am I missing? Reconstructed outline color. We should be doing this, but we're not. We're not. What's happening here with my outlines? The rendered, I don't get this. Let's see here. Accumulate, we accumulate colors behind this one in a kernel to be able to blur them. We have final color on this one, yeah. We just calculate a color, basically, the color we want to have here. We don't take the outline into account. But then comes the interesting parts. We do rendered color A is bigger than 0.0. Rendered color, we have a float 4 here. We read from a texture, we get RGBA. This one should 100% be true for this pixel, so I'm just gonna check one sec. Return. Yeah, it's white for this one. You can see here, it's white for all the outline. It's fucking beautiful. It's white for all the outlines that are in some way related to this water plane. That's why we're not seeing the white here, because yeah, it's not, the water plane is not rendered behind or in front of this one at all, so it doesn't affect it. But here we can see, so this one is definitely true for this pixel here. So what do we have then? This is true. Fuck, let's do this one as well. What the fuck, this, so it's true for this one as well. We have true for some points here as well. Yo, what's up, Little Miss Murder? A long time no see. We're getting along. Slowly but surely. Okay, so this one and this one returns true for this pixel. So let's see here. Did you sort out your flooding algorithm? Yes, I think we did. There are still a few things to just improve the visuals a tiny bit, the edges of it, but it's mostly okay. So we're moved on to working with the water shader right now, and we needed to adjust how outlines work with transparent objects here, because what we want to achieve is we want to do distortion underneath the water surface here, and I want to include these outlines in the distortions because I think that would look amazing. So that's what we're working with at the moment. This one returns true, this one returns true, so we are within this one. Reconstructed outline color. Outline color A. And here we do accumulated rendered color. Fuck yeah, it's gonna be rendered color A. Color RGB, blend, reconstructed. Yeah, I hope this one. Yeah. Lurk, Little Miss Murder, appreciate it, and how fun of you to drop by again. Okay, let's see what we have now. I think we got it. It's unoptimized as fuck though, but look at this. So we can blur whatever is behind here, and the outlines are unaffected. The outlines actually show what's behind. So if we blur the water, we should be seeing this outline here. The visuals of it changing a tiny bit because it depends on what's behind it. Which I don't know how well it shows on stream, but if you take a look at this pixel right here, why can't I zoom in more? Let's take a look at this. Unity, scene view, zoom in more than 5x. Or actually, no, it's the game view. Unity game views. There we go. The fuck? Exactly the same as me. Oh wow. Ooh. did it with Harmony. I don't even know what Harmony is. Yo, what's up, Love? Good morning, mate. Hope today is going well. Actually, it is. We just solved a problem we've been having, but then again, we solved it in the unoptimized way. And I'm just putting the optimization on future me's desk, so I don't have to worry about it right now. Hope you're having a wonderful day as well, Love. E-Dragon, what caused the blue screen? A few streams ago, it wasn't actually a blue screen. It was let's see here. So we're working a lot with kernels right now. So we're doing filtering on pixels, and it's extremely costly or memory heavy. It takes a lot of memory, and I mistakenly set the kernel size. So I mistakenly set the kernel size to be 110 times 110 pixels, which means, I don't know, 110. So we're basically doing 12,000-ish texture reads per pixel on screen, and we have 2580 times 40 times, what do you something like this. Yeah, I've limited it now, so I can't put the kernel size above 10. But yeah, so what happened was that my GPU ran out of memory, and my streaming software needs a certain amount of memory. So it was just that the stream got cut off because it didn't have the memory to send out into the ether. So no crash, no blue screen, but like almost. Yeah, I gotta be careful when working with GPU memory. Yeah, it was. So basically, it was just one. I mistyped one because I was gonna change the kernel size to from 11 to 10, I think. So I was going backspace 0, but I missed the backspace, I guess. So we got 110 instead. Oh yeah. But okay, so what we have now is we have outlines that are affected by color when it's behind something transparent, and if they are in front of something transparent, the outlines actually get altered a tiny bit to better represent what's behind them. And more recently, we can now also blur this, which means that outlines behind the transparent plane will get blurred. Outlines in front of it will be left unaltered. But yeah, then again, we can look at this. So if we play here, we're running with, if we don't blur anything, we have, let's drag this one down a bit. If we don't blur anything, we're running at, what is it, 250-ish FPS. But look how much the kernel size actually affects the FPS. So kernel size is how many steps do we move in the negative, positive X direction and negative and positive Y direction. So a kernel size of 1 is actually a kernel size of 3 times 3, so 9 elements. But that's just the outer kernel. Then we have an inner kernel that always depends on the outline kernel, and that one is always 3 times 3. So if we switch this one to 1 now, this one, we're actually doing 4 nested for loops. So we're doing 3 iterations times 3 iterations times 3 iterations times 3 iterations. So 81, I think, was the answer for that one. And yeah, it's definitely noticeable on the FPS. We go from 250 to 190. And now if I switch this one to 2, we're actually going to do 5 times 5 times 3 times 3. So we're going to do 2 to 5 iterations. So now we're down at 120. And if we go to 3, we're down at 80. Big blur. In this case, we can't really rely on default blur size either, because this one is going to take the pixels into account, because here we're working with MIP levels. It would be very nice if we could do it here, but we can't. But yeah, we're tanking the FPS, and yeah, yeah, the GPU is doing a lot of work here, and I'm gonna I think I'm gonna commit this. Nah, maybe not. Yeah, we're gonna do some. Let's see here. We're gonna do some cleanup and commit it, because we're gonna start experimenting quite a lot more now. But let me just explain. So it's basically this part, I would say, that is the code block that should be blamed the most for this performance loss we get. And basically its sole purpose is to, if we take a look at, I really wish I could zoom in more, but if we take a look at this pixel right here, it's part of the outlines, but it actually has a depth value of whatever is behind here, so the ground. It actually has a depth value of this ground here behind. And what this one just does is it goes through every pixel that makes up of, or goes through every pixel that decides if a pixel is an outline or not, and check if it's or actually like kind of sets its depth value to be the equal to the closest pixel within the outline kernel. So, to put it in simpler words, or to simplify it, not simpler words, but simplify it, it's a check or it's an additional check to, or to, it's a check to check the real depth value of the outline, basically. And what I would do if I wanted to optimize this, I would probably go, we would probably, instead of recalculating this every time for every pixel like we do now, we could store it when we calculate the outlines. We could store it in some way. Unfortunately, we don't have any space to store it or to communicate it between the outline and this water shader right now, or the transparent objects, because the output from the outline is basically RGB, which is taken up by the actual scene color with outlines applied. And then we have the alpha channel, and that's pretty much the only channel we can bake data into, and right now it just bakes it keeps track of the alpha of the outline. So all channels are used. We could, like I mentioned yesterday, we could pack both outline alpha and outline depth in the alpha channel. I just don't know what resolution we would have then. So instead of representing something with 8 bits, we do it with 4 bits, and yeah. So what do we have? But yeah, so yeah, this one, the most costly part. What we could do as well, we could actually do, I think we could optimize this a bit more. Let's see. Maybe not. Ooh, I should have. We should have committed this yesterday, definitely. Why do we use camera opaque texture here instead of main text? Oh yeah, I remember. Because when we're doing Blit as a renderer feature, we don't. So if you do graphics.blit, you actually get the first texture gets set to main text within the shader. But when you do Blit, like we do it right now, that doesn't happen. That's why we do this. But camera opaque texture. Yeah, this feels a little bit unoptimized as well. So but is this true? I like Blit in scriptable render pass. Hmm. Because what we're doing right now is that we enable the opaque texture in the project, and then we use this one here. We read it, calculate the outlines, we do the blending ourselves, and then we output it like this with the data in the alpha channel. I wonder if we could do this without the opaque texture like we did previously, and define some blend commands here in a fancy way so that we can still decide this one ourselves. But I don't know. What do we have? One zero source color source alpha. I don't like if we wanna. Yeah, when this one blends later on, it's gonna use the alpha, and it's gonna be extremely weird if we have packaged some data into the alpha channel as well. Then the blend is probably not gonna work out. Oh well. Okay, before I commit this, we're actually gonna jump to. Fuck, we have custom shaded graph nodes. No. Object shaders, transparent blur box. Yeah, I think we're gonna alter this one. Let's see here. Because we have blur, implement blur solution, and distortion. Implement distortion. I think we can solve, yeah, whatever. I think we can resolve these right now. Based on vertex normals, implemented based on normal maps. Yeah, so transparent blur box. We're just gonna alter this one in such a way that we can implement it still bothers me that we can't use, let's see here. It still bothers me that we can't use the default blur level. So this is doing blurring by utilizing the MIP maps. So you can see here it's pretty rough. But it's extremely cheap. It's a very cheap blur to do. But of course we can't do it with the outlines just yet, or not with the current implementation at least, because we generate the MIP maps from when the outlines are already applied to the image. Looks like JPEG artifacts right now. This deep fried. Here it works beautifully. Here it doesn't. What the fuck? Is it possible to solve this? Or should I just disable it? But one sec. Okay, what if we have opaque colors of the scene, and what if we take the outlines and we don't render them to the output just yet? We render outlines to its own texture. Do I wanna add an additional texture here? So basically after the outline step, instead of having one texture with both scene color and outlines, we have two images, one with scene color and one with outlines, and then we can, in the outlines texture, we can add some more data and stuff like that. We generate MIPS for both of them. This would probably be preferable, honestly. So if we had an outlines texture and one opaque color texture, how would that look in terrain procedural water? So we would be having, instead of this one, we have two opaque colors and outlines colors. And yeah, and then I think it might work. Because then if this is true, then we read from the MIPS of both of them. The problem, I would say, is still that we're gonna need to do a blit into the final image somewhere. Like we still need to do the final composition. Maybe. So when we're underneath the scene here and we have a default blur level, so when we go down a MIP level, if we're behind the surface, then we read it from both of them. so both the opaque color and the outline, and we mix them together. If we're above here, we just read from the opaque texture to do the blurring. So we're basically gonna get this result, but way cheaper, or even better. We could be getting this result extremely cheap, without these artifacts here, which would be amazing. We could even get 2. So we could be getting this blur level extremely cheap, without these artifacts. And one more thing, the most costly thing so the thing that brings us down to a very low frame rate here would be resolved as well, because if we have a texture that is purely for the outlines, we can pack a lot of additional data in it. Definitely. But yeah, I do wanna experiment with it, but I don't think we're gonna do that today. Okay, I'm just gonna take a short break, but when I get back, we're gonna commit this. We're gonna alter transparent blur box so that it works more like this water one, and we're also gonna make distortion work in this one. And then we're going to resolve some issues. We're going to create a new issue concerning experimenting with splitting up the scene color and outlines until the last second. And when all of that is done, I think we should manage to do that before I have to end today. Then we will start distorting the water. So basically, I think we're going to add some form of normal map on the water, which we're going to pan, and then we're going to distort. So when we read from rendered colors, we're going to distort the UVs so we get this, so that we fake the light distortion you get when you look at water in real life. What the hell is the word for it? Whatever. But be right back real quick. Okay, back. Let's see. Okay. First of all, I wanna commit this, I think. Blend. Outline color. Yeah, we don't need this one, or we can't use it. Outlines data. Your best thing would probably be to utilize this one as well. Anyway. Whoa, is these possible improvement? Improve outlines. Make outlines work with depth of field effects. Yeah, we're gonna have to do a custom depth of field as well. Definitely want this. Definitely want to be definitely want to be able to do this because I love depth of field effects. But we're gonna have to do our custom implementation, I think. Okay, so this one we can't complete just yet, but this one is actually related to. Let's do this one. So 93. Move to 93. Is it 1 or is it 2? I never remember. There we go. So we're gonna do it like this. We're gonna keep this issue open. Maybe we can depth of field. Let's clean this up a bit. Depth. Improve outlines. Depth of field. Is depth of field the actual name I want to go with here? Let's see. Add render feature. depth of field. Yeah, let's go with depth of field. Implement custom depth of field post-processing effect that works with outlines. Let's see. $94. Wasn't it 94? Yes, it was. Why am I not getting this one here? Okay. What is the word I'm looking for? We created two separate, more specific issues, 93 and 94. Let's do this. Moved two tasks into their respective issues. The two last tasks into their respective issues, resolving. Whatever. Okay. Blur, distortion. Well, maybe I was a little bit too quick on resolving this one, but improve outlines. No, I don't think so. Let's see. we're gonna commit this one and we're gonna do it let's see. I want to add okay, so what we actually did here is we added a custom blend solution to outlines. To better work with, and then we reference 71, 73, and 94. 71, 73, and 94. Ah, fuck. Ah, beautiful. Okay, and then I want to do, let's jump to transparent blur box. We're going to work with this a tiny bit. Remove this, this, and this. So this one basically does the exact same thing we did with the outlines, and we want to work with this one again. So I wonder, let's see here, not outlines but terrain procedural water. I wonder if we want this one do I want to put this functionality in its own utility file, because we're going to use it on multiple places. 9 is 9. Yeah, maybe. Maybe I'm gonna... Would it be a good idea to put everything outline related into its own utility file? We could, for instance, work with, so outline color, outline kernel size, we could have those in that utility file. We could probably have this as well. Yeah, we do this exact same thing. But not as good. This we want to keep as it is. What we do, normal OS, okay. Let's just duplicate the code here for now. I think rendered color. Oh, here we do the let's add this object and see what we can do. Pixel depth 1. Oh yeah. Okay, what I want to do is we're going to pause this scene sphere. this one. Main texture kernel size, no. Actually, don't we have any material to this shader yet? I thought we had. Particle prototype samples use. Let's do prototype material transparent. We have blur box here. Yeah, we do. Let's go with orange. Let's see what we get. That's the wrong sphere. Kernel size 4, we're gonna chill with that. It seems like it doesn't matter, the kernel size doesn't matter, we still just blur once. Okay, have I screwed these up? Yeah, maybe we have. But do we have distortion power? Yeah, we just distort the outlines right now. Yeah, it doesn't really work with the way we do stuff, so let's just fix that real quick. Rendered colors. Basically, we just want to do this again. And then we would like this one in outline kernel size. Yeah, of course. final color. Where do we use that one? Here, okay. Blinn Phong lighting. We don't really do Blinn Phong here, I don't think. We just do output color, so final color input dot color. Just color. I want to do some cleanup in this one generally. Oh, yes. Yes. We just want to do, we don't want to I.color, we want to do color, I think. What the fuck? There we go. And can we distort it? Yes, we can. And how does the outlines work? Okay, I guess. Maybe not the best distortion, but it's actually pretty damn good. A little bit better than the previous one. And then we can blur it as well. Yeah, this is what we're going to use for the water later on. A lot of these. Same mechanics. And how does it look if we go in front of it? Yeah, then we're fucked. We have this going on here, and we have this going on here, and it's only related to distortion. So I want to get to the bottom of that. Distorting outlines. It's a little bit weird because we're doing distortion here, and everything we do with distortion is we just change UV center to be distorted. Linear eye depth, sample scene depth. Yeah, if this one is bigger than pixel depth, yeah, we definitely want to check this one. I think. Okay, similar problem that we had previously. We no longer, like, we pretty much just remove it here. We don't distort it anymore, but we only remove it. So let's fix that. We can also see we get issues like this. That's not pretty at all. And honestly, I'm not too... I don't even know if this is... this is one of those distortion problems or artifacts you just have to... possibly just have to accept, because it distorts in such a way that what we want to show here is actually something that is behind the character and we don't even render it. So if you want to go distortion like this, you might need to, like, you can clean it up, hack it, but you might need to work with some cube map of some sort. I don't know. Honestly, I don't care that much about this for now. But what I do care about is the outlines disappearing here. Why? I'm pretty sure it has to do with this one right here. So I'm wondering if we want to keep this one up here instead. Works. Not really. Same problem as previously, right? This one, rendered color, alpha. Fuck, do we want to distort it? Same problem. Nah, I'm pretty sure we want this one here, because we want to see if there's an outline. Could it be? Probably not, but let's take a look at it. Final color. Color bling fong. No, that's not it. Color accumulated rendered color. If rendered color is bigger than this one and this one. UV center. UV center distort. Fuck. We're gonna do original, and then we do float to UV center is equal to UV center original. Here we do this. because I think we need this one. I wonder, I don't think we want it here, no, but I do think we want it here. Okay, yeah. So now we only have this problem left, and I'm not entirely sure. I'm gonna have to research it. I think, if I remember correctly, like, there's only so much you can do when utilizing the screen space color or the rendered image to create beautiful effects like this, distortion and whatnot, because we don't actually know, we have no idea what's being rendered behind the character here, so we can't really distort it if we don't know that. Extremely ugly artifacts though, but I wonder if there's some, maybe the distortion algorithm is a little bit off as well. Oh well, we pretty much had this in place. I just wanted to get it to work with the previous solution. We're gonna have a few problems though. Not as bad as these, I don't think, but like, we're gonna have the same problem we have with this sphere when we're here. So when we distort whatever we have below the surface, we're gonna do it by, instead of using like the spherical normals, I think we're using n.v to distort the UV. We're probably going to do something similar here, but we're going to have a normal texture on here, which is going to distort the normals of the surface a tiny bit, and we're going to pan it, and we're going to have to, when we want to read values from below the surface, we're going to distort the UVs by these distorted normal values. And for instance, when we read this value right here, and we might get distorted, so we want the value here, but we don't have that value in the rendered, like the scene colors, so we don't know what's behind here, so we're going to get the similar artifacts here. So that's going to be one big problem to handle, but I think we're going to be able to solve it. And here we have another problem, but this just has to do with a plane. What do we have? 2000. Oops. We have a little bit of a mismatch in the sorting here. So we draw the water above this one. I thought we had Thought I had this figured out. Render scene color effect, render scene color dependent objects, common transparent. Yes, fuck. Okay, we're gonna have two big problems to solve. This one should be a little bit easier. We just need to order them. I guess this is because common opaque. Yeah, we're gonna have two big problems here. Okay, first of all, we definitely want to render this orange above the blue one, not the other way around. That will clean it up a tiny bit. Like this, but we still don't get the water behind it. And that is going to be a hard one to crack. If we're gonna have to do I think we're gonna put this into an issue. Actually, one sec. I don't think we will get the correct result here. Yeah, we'll always draw this one above. $2,000. Oh, wrong one. This one, 2,000. So we have a problem with the depth. So we want to configure target. I think we want to do this. Maybe. It's probably, yeah, what the fuck. Terrain procedural water. I wonder if we can write to depth this late. I don't know. Yeah, okay, so this is way better, but it doesn't solve. There's still one very hard problem we're gonna have to solve. And what is this? What's going on here with the edge? What's going on with the edge here? Yeah, there's okay. So we have two issues that are gonna be extremely hard to solve, and like I'm even questioning if they will be solvable or if we're just gonna have to do our best to hide them. And it's going to be transparent object on top of transparent object, much like we have here. Given how we do stuff right now, the data of this transparent object doesn't exist for the water, so we can't draw it. And like you can't see the water through this one. And then of course we have the distortion. Like this little issue right here, that we aren't able to distort what's actually behind the character. So two things. But I'm not gonna worry too much about those until like we could exclude those cases by just not designing around the possibility of having two transparent objects on top of each other. But one scenario I can think of, or I've thought about multiple times, that highlights the first one of those issues is, for instance, if we have a monster that is a blob, definitely want a blob monster, and if we want to go crazy with the visuals of the blob, we might want to go with a transparent material for it, and we might even want it to distort whatever is behind it. And yeah, so then if you have that blob jumping into water, you're gonna get a lot of problems or artifacts. But then again, yeah, I don't know just yet about that. But now I'm wondering what's going on here. What's this? I'm pretty sure it's something with shadows. It's a shadow artifact, all right. You can see it going like this. But why are we seeing this one here? What do we do? Terrain procedural water, and we jump down to here, Shadowcaster. I don't even know why we would have a Shadowcaster here. I need to think about this one. Do we want the water to cast shadows? Nah, I don't think so. So I think I'm leaning towards, we even have the wrong name on it, we just basically copied it from Grass. We're gonna remove the Shadowcaster from this one. Okay, one thing I want to do here now is I want to resolve this issue and this issue. But before I can resolve this one, we need to implement this one. Okay, but what I want to do is, we can see here that transparent blur box, so my default transparent material that can be blurred and distorted, and terrain procedural water, they share a lot of code. I'm talking about this segment here, and this segment right here, this segment right here, and this segment right here also. I think we're gonna put introduce a new utility file here. Utility blend. Helper function, that's a generic name. Just grid. Probably want to rename this one as well. Util lighting, util math, and util random. This is filter based. Yeah, we're probably gonna go with like utility filter, I think. And this is basically a average filter, right? let's do it. So new file, util filters, utility filters. And we're gonna have get smallest depth filter. Yeah, that's okay. On roll 99, fuck, I want to define. Can we define a const int, or we can define it like this because we want the compiler to work with it. What do we do? A macro, because I want to replace these max. Oh, fuck, let's see here. HLSL define compiler variable. No. Or actually, we have it in, let's say, util math. There we go. Define max filter size, and we're gonna say 10 for now. 10 times 10. That's insane. 10 times 10. Can we do this? Get smallest depth filter. Yeah, that's one filter, I guess, of sorts. Smallest depth, max kernel size. Yeah, it works. So then we do transparent blur box. We want to include util filter, and then we can remove this one from here. think. And we want to do the same in water. It's starting to grow into a pretty sizable list here. Water, 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 water. Oh yeah, util filters. Get smallest depth in kernel. Yeah, we renamed it to get smallest depth filter. Although I wonder. Okay. Although I'm wondering, get smallest depth filter UV center original, UV center distorted. Okay. Yeah, there's a lot of filters going on here. Frog Boy, what's up? We can put all of this and probably even this. I think. Util filters, we're gonna do a float. Get. Do I want to do get? Do I want to have get in the names, or should we just do so smallest depth filter, average color filter, smallest depth filter, get smallest depth. Actually, get smallest depth filter, it's, one would assume that this one returns a filter. Apply smallest depth filter maybe. Fuck, here I would like to send in texture 2D and a sampler. Let's see. And that's really what we want to do. Unfortunately, we don't use this one. We use, unfortunately, we don't use this one. We use these macros. Let's take a look at those. That's pretty cool. Frogboy, what is your favorite game engine? Unity 3D, or Unity for short. But to be fair, I haven't spent nearly as much time in any other engine as I have in Unity. How about you? feels a little bit weird to have these in this one, but okay, so we want to do, I wonder if we can do it like this. We have this one here as well. Oops. I just want to know texture 2D. I just want to know what the hell we're working with here. wonder if it's the sampler 2D, something like this. Lavendary, thank you for the follow, appreciate it. Or Charlie. Okay, did we not get any errors here? Is this maybe how we want to do it? Return 0, average color filter. Let's just try and call this one. I'm a little bit... let's do... accumulated color. We do sample texture 2D LOD, we do text, and we do sampler text. Blur level at 0. Lavendary or Charlie, I don't know which one you prefer. Saw you a few weeks ago on YouTube, you're awesome, keep going. Thank you, I appreciate it. And I will. We don't have any ifs here, so we're just gonna, we want to return a float 4 here, and we want to return divided by count. I have no idea if this will work. Sample level, no matching 3 parameter. Interesting. Oh, is it a sampler state? Is this how we want to do it? Okay, let's put it to the test then and see if we can. Average color filter, let's just send it in, and we do procedural water. Let's just try a return average color filter, and what do we want? UV texel size, kernel size, rendered colors and sampler rendered colors, and that's about it. UV 248. Yeah, we want to go UV center. Oh fuck yeah, it works. Beautiful. Okay. So yeah, average color filter. We're also gonna do int MIP level. Okay. So now we have an average color filter, but we want to have a average color filter with outlines. Is that what I want to call it? Average color filter. Yeah. So this one pretty much just loops through the texture in question and take the average color. Now when I think about it, we could probably use this one in outlines as well. But there's a lot of things we want to do. Float 4 average color filter, average color with outlines, or average color outlines dependent. Average color outlines dependent filter. Average color outline dependent filter. Float 2 UV center, float 2 texel size, int kernel size, texture 2D, float 4 text, sampler state, sampler text, MIP level. And we pretty much want to do previous depth. We don't use this one anymore. We want to use pixel depth. Or we basically want to do all of this, all of this, and we want to do this as well, but this one, let's see, never mind. I think we want to do this as well, so we might do This one we need to send in. So let's see a rendered color. We want to do a rendered center color. Accumulated. Count kernel size. Fuck, do we want to do unroll here as well? I think so. UV and then get smallest depth filter. UV texel size. Pixel depth. Accumulated color is equal to text. Sampler text. MIP level. And then after all of this, we check if count is bigger than 0. If so, we do accumulated color. We do the average of it. Otherwise, we just set it to rendered color. And I think that, or center color, that is. And then this one, let's see. First of all, we do a blend here between final color and accumulated color. So, yeah, this sucks, because now we're gonna have to send this one in. But accumulated color, yeah, it's this blend I'm not okay with. We take final color, we calculate, and we blend it with accumulated rendered color. Source destination. Yeah, this, what we're doing here is pretty much a blend, but we take outlines into account. We could do an outlines blend, sending this one, but reconstructed rendered color. I wonder if a better option would have been to make this more outline specific, so we just handle everything with the outlines here. So it's a outline utility instead of a filter. Average color, outline dependent. So fuck this, but we might want to do this on somewhere else. But this one is pretty much, this is a blend source alpha 1 minus source alpha, but where we take outline into account. So with the current file setup, it probably belongs here. But this one takes, it needs rendered color alpha here. Fuck. So many decisions. Basically what we're looking at is replacing all of this with one method call, ish. Then again, pretty sure we're going to use this in a lot of different places, so it would be nice, very nice, to have it in a presentable way somewhere. Oh, what the fuck, yeah. I guess the best way would be to send in this color as well. So average color outline dependent filter, but then it becomes a blend. It's a mess. Calculating average color, we could return it after here, but then we're gonna have to read this one again, I guess, or this one again. Accumulated color. I guess we could just, we couldn't handle that one outside. So we can save this to center color. Let's just remove this one and let's do count. And then we just return accumulated color. So we might return it as 0000. That might actually be the accumulated color though, so can we do out then? Yeah. One sec. Yeah, now it's just a question of how do we handle it if, let's say that we're doing a filter and none of them passes this test. Accumulated color, but if none of them passes this test, then I don't think that should ever happen. In that case, I guess we can do if we just return this. And then we handle this one on the outside. And would that be too bad? So how can we simplify? So pixel depth, we need to send this one in. Let's see here. Yes, fuck. When does this actually happen though? When do we have accumulated color count that is equal to 0? I don't know. Does it ever happen? Because then it's, maybe we can check this out, but when we do the final blending here, it would be extremely weird. Let's just try it. So float for color is equal to this one, average color outline dependent filter. UV center. Pixel size, we can probably kernel size, then we have the texture, and that is going to be rendered colors, and then we have the sampler, and then we have the MIP level, which we're gonna do default blur level. And finally we have pixel depth, which input.position vs.z. Pixel depth. So let's remove this. So we calculate color here, then we do color blend final color, and then we do this. We have pixel depth here though. Yeah, so this one we want to store. average color outline dependent filter. So we get a color here, then we take that color and we blend it with the final color, and then we do these checks. I don't know. I'm a little bit worried about the fact when we check 3x3, so when we check the full filter and we don't actually have any color that is in front of, it's a weird use case. Did I screw up the unroll here? Yeah, maybe. So what I'm gonna do is we're gonna leave on a cliffhanger. We're gonna continue this tomorrow. We're not changing the implementation here, we're just modularizing it so that our code is a little bit better or cleaner. But I'm going to continue this tomorrow because I need to run. So thank you so much for watching, everybody. Sorry about the cliffhanger. Have a great rest of the day. Peace.